We're going to go ahead and take a look at tangent, secant, and cosecant graphs in this video. Now, a lot of girls like the tangent graphs because most girls like looking at tangents. Now, the tangent graph is given to you right here. It starts at the origin of 0, 0, because when you think of your tangent of 0 degrees, it's 0. Then if you go tangent of 30 degrees, that's root 3 over 3, and you do your approximation of that. Tangent of 45, you know, is 1. Tangent of 60 degrees is root 3. And if you would do a few other points other than those, you'd be able to plot them, and then you would have this smooth, blue, kind of snaky graph right here. Then we have a vertical asymptote. We have a vertical asymptote here because at 90 degrees, tangent is undefined. Because remember, tangent is y over x, and on your unit circle, the y and the x would be 1 over 0, and you can't divide by 0. And then this whole shape just is repeated over here. Now your period is how far you have to go before it repeats. Well, you could see that it goes between this asymptote and this asymptote. So that's 90 degrees to the right, 90 degrees to the left, so that's a total distance of 180 degrees. You will be expected to know the basic shape of your tangent graph and where your vertical asymptotes occur. Now, on some graphs, there's amplitude, which is how far up and down you go. There is no amplitude with tangent because it goes up forever, goes down forever. Now, let's take a look at your secant graph. Secant is a reciprocal of cosine. So all I did is I just put my cosine graph in here, and I put it in as dotted because it's not really part of our original or our secant graph that we're going to be dealing with. So here our cosine is 1, so the reciprocal of 1 is 1. Here our cosine is 1/2. The reciprocal of 1/2 is 2. If we do the reciprocal of this, it's about 3/4, and that is then 4/3, so 1 1/3. If we do the reciprocal of this is about a height of 1/3. The reciprocal of 1/3 is 3. And we could do the same thing over here. This is about 3/4. Reciprocal of that is 4/3. Here our height is 1/2. Reciprocal of that is 2. Here we're at about a height of 1/2 or 1/3. The reciprocal of that is 3. Now this is shaped right here is also identical here. So these points that we have right here will also show up over here in the same locations. But let's take a look at this part that's negative. The reciprocal of a negative is still negative. All it does is flip the fraction upside down. It does not change the sign at all. So here we have -1. We flip that upside down, we get -1. Here we're at about -3/4. The reciprocal of that is -4/3. Here we're at -1/2. The reciprocal of that is -2. Here we're at about -1/3, so the reciprocal of that is -3. And similarly over here, reciprocal of about 3/4 negative is about -4/3. Reciprocal of -1/2 is -2. Remember, reciprocal means you're just flipping your fraction upside down. So we have these vertical asymptotes here. We have vertical asymptotes because at 90 degrees, our cosine was 0. But when we do the reciprocal, that would be 1 over 0, and we cannot divide by 0. So now, if we draw a smooth curve in connecting all these blue points, we get this blue curve. Similarly down here, we get this blue curve. And when we draw this one on, we get this blue curve. So what you see here in blue is your secant graph. The secant graph is only the blue. It technically does not include the asymptotes, and it definitely does not include what we started out with our cosine. But we use that to help us see what to get. Now, when we're looking at this, our period is 360. We know the period of cosine was 360, and all we did was flip it upside down, or not flip it upside down, but do the reciprocal, so our reciprocal function will also have a period of 360. You can see here that you have a full horseshoe up, full horseshoe down is one full period, and then it starts over again. So we're going from 90 degrees to the left to a total of 270 to the right. 90 and 270 is that 360. Now we'll take a look at our cosecant graph. Cosecant's the reciprocal sine. So I have my sine graph in here. I put in wherever my sine is 0 and I flip it upside down, that's where I'm going to have vertical asymptotes. Sine is 0, flip it upside down, vertical asymptote. Sine is 0, flip it upside down, a vertical asymptote right on my axes. So now, once again, I want to do all those reciprocals like I was doing before with the cosine. Reciprocal of 1 is 1. Reciprocal of 1/2 is 2. Reciprocal of 1/3 is 3. Reciprocal of 3/4 is 4/3. And you can see that it's going to be very similar to our secant graph we had on the other page. And you would expect that because your sine curve and your cosine curve are the same. They're just shifted over compared to each other. So you would expect the reciprocal functions to also be the same shape, just slid over from each other. So we have our cosecant graph right here in blue. And that continues on in each direction. Now let's connect these points with a smooth curve. So we would have our cosecant graph in blue. It technically does not include the asymptotes, but they're often put on there for the sake of seeing what's going on. It does not include what we had for our original sine graph. Your cosecant graph is only the blue. So your cosecant graph is a horseshoe up and a horseshoe down. You can see that you start at 0, go over to 360. Once you get beyond 360, it's a horseshoe up and starts to repeat. So your period is 360.